Hey friends, this is Dom, one of the CNCF Pixie maintainers, and today we're going to be tracking down a bug in the way that Pixie is capturing the data of certain short-lived processes. For those that don't know, Pixie is a Kubernetes observability tool, and after you deploy it, you'll get nice visualizations and deep introspection into your microservices. You can see here, since Pixie understands all of the RPC messages, we can really understand how our microservices are connected. We also can dive deep and see every HTTP request in the cluster. Now, I've just started a curl command from this bash pod, and the command that I've ran is basically just looping from 0 to 1,000 and running curl with that increasing integer at the end. So in theory, we should see request 0/0 all the way to /1000. Unfortunately, we can see we're missing quite a few records. And so this is what we're going to be tracking down today. So before we dive into the code, and just to be clear, this is when making a request external to the Kubernetes cluster. So before we dive into the code, we need to understand better on what's happening here. So all of Pixie's visualizations are based on our Pixel language, which is essentially Python. If we add these compiler directives, we'll actually get an understanding of what the query is doing, and that will help us to better understand the code that we need to work with. So I'm going to copy this string. It's just .viz, which is essentially like some graph representation, into a online editor so we can see what that query is actually doing. So after pasting this in, I can just download the file, and this is essentially what the graph is right here. But so what we can see is there is this upid to pod name lookup, and that will be important. But one second, let's go back and just look at this data in a little bit more detail. So because I'm familiar with this Pixel script, I know that we filter out anything that has an empty source or an empty destination. Let's uncomment that briefly for now. And oops, I need to remove this filter as well. And so if I'm going to try and look for those requests, I need to probably sort the other way. And also up our max num records so that we're making sure we get everything. So, okay. All right, so we can see here, we actually are seeing all of the records, but this source column is blank. And so as I mentioned, when we're filtering this out in the default script, we're actually hiding the records, even though they exist. So essentially what's happening is, so Pixie captures traces on the server side by default, but if we don't capture it, we fall back to client-side tracing. I'll definitely be doing a video on this later, but for right now, you'll just have to take my word for it that this is a case where we're reaching externally to google.com, and so we actually have to trace the client. So, but all that's to say is that this source field is going to be based on this df.pod, and that's because this is a client-side trace, so we're going to get this second false case. So what I'd like to do, so we actually have multiple, so this df.pod is based off right here. And this df.ctx is sort of some like syntactic sugar that we provide in order to look up Kubernetes metadata. Now, I think, so we're going to look at how the compiler generates that, and that's basically what this function is. We'll validate that once we start looking into the code. But I believe there's another lookup that we can do that will make this syntax work. So I'm going to do new source, And I'm going to do another px.select. And so we're going to say df.source equals empty string. If it's an empty string, so I know for local or for client-side traces, we have a df.local address field. And this will actually correspond to the pod IP address. So we'll add that up here in addition to the new source field that we're going to create. And so we're going to, and actually we'll keep the is server side tracing too, so we can also prove that this is client side tracing. All right, so now let me just finish this up. So if we have the local address, Pixie actually has ways to look up pods from other things. So we have IP to pod ID function. So I'm going to do the local address here, but that gives us the pod ID, not the actual pod name. But there's actually another function, pod ID to pod name. And if I just, yeah, so basically, if the source is empty string, we're going to do this new lookup. Otherwise, we're going to return df.pod or df.source actually. Okay, let's run that again. And so if we go back to looking at our data, here we go. So we can see here, source is blank for the majority of the requests. There's a few that we get right, but this new source column actually has it every single time. And, just to validate that I, explain this, these are client-side traces. So what I'd like to do today is we're actually going to change Pixie's CTX pod sugar to do the normal lookup that it does, but in the event that it's an empty string, we're going to fall back to this new implementation, which is essentially these additional function calls. So, and like we talked about with this DAG, we'll verify this in a second, but basically this is the function that's not working properly for these use cases. All right, with that, let's dive into some code. So we have this thing called the logical planner, and I'll just stop my pull request. The logical planner basically lets us pass in pixel code and test that it compiles and will successfully run. So what I've done here is I've added this test that does this pod lookup, the CTX syntactic sugar. I've also, there's code here where we're taking what we call like a metadata IR or intermediate representation, and we're turning it into the function call that we want right here where this function name thing is defined. I've just added logging here, this creating conversion function, just so we can verify that this matches this UDF or UPID to pod name that we have here. And then we'll dive into solving this problem. So let's run this test really quick. So we can see here, when we run that pixel code, we're getting creating conversion func UPID to pod name. So hopefully that just kind of ties the pieces together that this is the function that needs the fix. And so with that, let's dive into things. So the UPID to pod name function, we have this function registry, and so we can see here that it actually is defined by this UPID to pod name class. So I'm going to go there, and we can see when it executes, we get our metadata state, we get the UPID to pod name from the UPID value, and if it's null pointer, we're returning an empty string. Now, the way I think we need to do this, we could have the compiler wire up different functions, sort of exactly as the pixel that I showed. But I think what would be better is let's detect when we can do this fallback case and swap in a new function. So I'm actually going to copy this whole thing. And we're going to call this upid to pod name local ADDR fallback UDF. And I'm going to ignore this doc thing for right now, and I'll probably add a comment saying it's a compiler internal thing. But for right now, we're only going to focus on the guts. So if we come back to the pixel that I wrote, in order to call these functions, we need a local address. And so this function is going to need more than just the upid. So we're actually going to need the local address, and this is going to be a string value. And then there's actually two different ways to do this IP to pod ID. So, you know, we can see here, this is that function that we called. But there's actually this one, IP to pod ID at time. And so not only does it take the pod ID, but it also takes the time. And this function is a little more resilient to cases where you have IP addresses getting reallocated to another pod in the event that you have short-lived pods. So we're actually going to use this sort of style. And so actually we're going to basically need to call this exact same function. So I'm going to copy this, jump back to our implementation, but this is going to be time 64 NS value, and we'll just call it time. And so what we'll do is we'll do the same lookup, and if this is null pointer, we will then issue this fallback. So auto, this is pod ID, and then we will need to do, yes, I believe that's right. Let me just double check that. So that corresponds to the function pod ID to pod name. And so, yeah, metadata state pod, yeah, great. Okay. All right, cool. So now that that's in place, what we need to do is, so now that we have this UDF defined, but we also need to make sure it's registered, which is basically what this line was down here. So I'm going to open up this other function, this other file, UDF to, or upid to pod name. This is going to be upid to pod name local ADDR format. UDF. Now, you can see there are these underbar prefixed functions. If we come back to the Pixie UI quickly, so Pixie actually has a pixel script that lets us see all of the functions that are defined in our Python. And so, you know, if we look up, for example, upid to pod name, we can see it exists right here. However, that one that we just looked at, the exec host name, if we jump back to the browser, there is no exec host name. And that's, so basically we have the ability to hide those functions from the public API if we prefix it with an underscore. So I'm going to do that same thing. So this is going to be underscore upid to pod name local ADDR fallback. All right. So that should make our UDF accessible to Pixel. And now what I'm going to do, so Now we need to come into this. So our compiler essentially has analysis steps and optimization steps. Where we handle this metadata is where I added this log statement that we saw printed out, but it's called convert metadata rule. And we basically take a metadata IR node and we turn it into the UDF that it corresponds to. So we have a whole bunch of other syntactic sugar, like you can do CTX of service, CTX of deployment. So we only want to opt this into the one that corresponds to this pod name lookup. And so what we will do is this parent resolve table type here actually tells us the columns that are present. And so we're going to need this information because we're going to have to look up that the time column and the local address column are present so that we can opt ourselves into this new function. And we can actually see that here because this find key column, sees if the parent has a given column. So what we're going to want is we're going to have as backup conversion available, and we'll pass in table type. And we'll also need the UDF name. So let's move this down here actually, because we want to know that it's the upid to pod name function. Backup version available. Okay, cool. And then we'll have conditional logic based on that. Like if it's available, we will then do something new. Otherwise, we'll do the same conversion func before that only uses one column because all of the metadata names are like key column to return value. And so in order to make this work, instead of declaring and assigning the variable here, we actually need to just make sure we're just assigning it. And so that means I'll need a func IR here, conversion func. Okay. And then when the backup happens, we will instead create some additional columns. So we can keep the key column there, but we will also need columns for the time field and the local address field. Px assign or return, and this is going to be column IR local ADDR column. Great. Copilot knows exactly what I want. And then let's give it some hint. Create time column. Perfect. Exactly what I wanted. Now we need to pass these in the same order of the function that we created. And so it's going to be upid value, local address, time. So if we come back over here, we'll do upid, local address, and time. Great. Awesome. So this is essentially the scaffolding of what we need. Oh, I didn't implement this function yet. Has backup conversion available. So let's do that. And then we have some unit tests for this class, for this rule, and we'll make sure that the existing tests still pass because we shouldn't be using a different function name. Oh, and actually I realized there's a bug here. We're just using func name here, but we need, in the backup case, this needs to be underbar upid to pod name. If we grep this again, yeah, it's this name right here. Great. All right, now let's make this backup conversion function. And it's going to return a bool. And that is exactly the function definition that I wanted. Now we're going to say return. I guess this is kind of what I wanted, but I'm going to say return func name equals UPID to pod name, and the parent table has local address and it has time. If it doesn't, then we'll just use what we had before. Cool. So with that in place, I'm going to leave this log statement in there just for right now, but our test file is called the same thing, but it's suffixed with underbar test. And so I'm just going to use Bazel here to run that. Compiler, analyzer, convert metadata rule test. I just need to make it a target name by using that colon. All right, I fixed a few compilation issues, but the function essentially stayed the same, but we have passing tests, which is great, meaning we didn't break anything. So I'm gonna go over to this convert metadata rule test now, and we need to add a unit test for this fallback case. Now, what we can see here is essentially what this test does is it asserts that this funcIR has the UPID to pod name function, and it has one argument, which is the UPID column. So essentially, we're going to do this exact same thing, except we need it to verify that there are 3 columns and that they match the expected, local address and time. So fallback case, and I'm gonna give it a name. Yeah, we still want that, but I'm just gonna change right here. So we expect this to be UPID to pod name local ADDR fallback. And then we expect there to actually be 3 arguments, 2, 3, and we'll call the input column UPID column. And then we will need, this one will be local ADDR call. And then we need time call. And we'll just have the match. And Copilot to the rescue. Great, and now we just want to make sure that the data types are evaluated properly as well. So expect EQ types, data type, string. Yep, and then also the time column, which should be the NS64. Need to double check that quickly. Should be time 64 NS. Actually, that's not the right area. It's type.proto. Time 64 NS. Great. Okay. Awesome. I think that should be it. Let's give it another run and see if there's any issues. Okay, so yes, it did not match. Oh, I forgot something. Our test, the relation that the data table is using only has a uint 128 column, but we actually need to add the local address, call conversion string. Okay, yeah, so this is going to be local address, and then we need to also add the column for time. And after doing that, our opt-in should apply, and we should get the correct function name. Fantastic. So now I'm going to clean this change up a little bit later, but the next thing to do is let's scaffold this to our Kubernetes cluster, verify that this issue is no longer happening, and also check that .viz of the directed acyclic graph to make sure that our function is actually showing up.
The scaffold deploy has finished, and I restarted the curl workload on the cluster. Looking at each of the entries in this table, we can see there's no longer gaps. We are seeing all of the curl commands happening. The final thing to check now is to look at the graph representation of this Pixie query. So I've went ahead and regenerated this, but if you add these compiler directives and check in the data drawer, you can follow this process as well. Hopping over to that graph viz visualization, we can see here that right after the data is read for the data tables, the first map operator is calling that local address fallback function. So thanks for watching this video, and hopefully you've now seen this process fully end-to-end. It also shows the power of Pixie having its own query language and us being able to swap out the implementation so that people's configuration can stay the same, but we can continue to optimize queries, fix bugs, and ultimately build a great observability tool. I'm going to continue these YouTube recordings, so I hope you join me on future sessions. Thanks.